Hello, this is Sean McGowan doing my video submission for Lab 2 of ENME 351. So for this lab, we were looking at the hardware and coding for the Arduino and doing various things to a simple circuit involving an LED. We would make the LED blink faster, slower, and fade in and out using two different methods of coding. And at the end, we have our own little fun personal project that we did using what we've learned. So with that, we'll get right into the lab. Take it away, Sean. Oh, thanks, Sean. And with that great introduction, we'll start here at the pre-lab. Here you can see our pre-lab questions written out as well as our answers, and you can pause the video here to examine them further. So for part 1, we were to use the blink example code provided here to make our LED blink. For part 2, we were to take the same blink example code from part 1, but add an integer called delay length. We add this integer so we can easily change the length of time that the light takes to blink on and off. Here, I change it from the original 1000 milliseconds down to 500, then down to 100, and then finally 10 milliseconds. I stopped at 10 because this was the delay time to where you could no longer tell the LED was blinking. For part 3, similar to part 1, we use the fade example code from Arduino to implement into our circuit and fade our light in and out. We can change the duty cycle of the light by changing the brightness integer in our code. In part 4, we're looking at the example code from part 3, but we're converting it from analog write to digital write. I go over the differences between the two codes in my pre-lab. In my code, you can see that I have an integer called level time, which allows me to hold a particular brightness level for a certain amount of time. In my 3 examples, I start with 20 being the longest, 10 in the middle, and 5 being the shortest. I also implement the 2 millisecond PWM period in each for loop, which is usually implemented normally by the analog write command. In each example, we can see that when the LED reaches its minimum and maximum brightness, the LED will blink twice. The advantages and disadvantages of using the built-in PWM versus manually typing it is using the built-in is a lot less time consuming, needs a lot less code, and is a lot less memory consuming. While using the manual code, I am able to have more control over the time spent at each brightness level and the amount of increments that brightness has. For the final part of the lab, we were to have a little fun and create a little project of our own. So when I saw the blinking example earlier in the lab, I got inspired by the Ford Mustang turn signals, how they'll light up sequentially left or right. So what I did here was I created and coded my own turn signals. I coded 2 modes in them, which I can control with this potentiometer. If I turn it to the left, it's in manual mode. If I turn it to the right, it's in automatic. So it's in manual mode now, so I can light up each light individually using this potentiometer. If I turn it to the left, light up 1, 2, 3, and back down. If I turn it to the right, I can light up 1, 2, 3, and turn it back down. Now say it's too much work for you, I can turn on automatic, and it'll do it automatically. I can turn it to the left, and I can turn it back to the right. Now say that blinking's not fast enough for you, I can change one variable in my code which will make the blinking a lot faster. To the left, and back to the right. And lastly, here's my code for the final little fun project. The manual mode is a bunch of if statements going through increments of the analog read provided by the central potentiometer, and the switch integer is related to the left potentiometer and is able to switch it between the manual and automatic modes. I'm also able to change the blink timing by changing the BT integer at the top of my code. Alright, that's it for the lab. I hope you enjoyed, and I'll see you next week.